Hi, everybody. Welcome. I'm Faith from Elastic's community team. Today's meetup, CISO Enablement Track, Advanced Threat Hunting and Monitoring with Elastic APM, is brought to you by Capgemini's Insights and Data Meetup group, as well as Elastic's AMER virtual user group. So today's topics, the first is going to be CISO enablement with preventative, detective, and responsive solutions. That's going to be brought to you by our friends at Capgemini Financial Services, Ayush Sharma, Ashwin Parmar, and Rajesh Iyer. And then the second part of our presentation today is going to be from Elastic on advanced threat hunting and monitoring with Elastic APM, and that'll be presented by Ruben Perez, who's a solutions architect here at Elastic. So a few notes. If you're coming to us from the Elastic virtual user group, we encourage you to check out Capgemini's Insights and Data Meetup. It's a great place for networking, and I'll send some links into the chat to the regional groups that we encourage you to join. Yeah, so without further ado, I'm gonna hand things off to Rajesh.
Hey, thank you, Jennifer. Good afternoon, everybody. My name is Rajesh Iyer. I head up the Artificial Intelligence Group for Financial Services at Capgemini. I'm here along with my colleagues from Capgemini, Ashwin Parmar, who's my boss and heads up all the different practices area within Capgemini. And then I also have Ayush Sharma, who's our go-to-market lead for Capgemini. So if you have any questions that you want to get a hold of us on, Ayush Sharma is probably your best bet. With that, I'll start my presentation on cybersecurity analytics. Before I step into that, I want to spend just a few minutes talking about Capgemini itself. For those of you that haven't heard of Capgemini or don't know a lot about it, we're about 50 years old company. We started in 1967 out of France. We're fairly large right now. I'd say it was considerably larger than that at this point in time. We're a global leader. We provide three kinds of services. One is along the lines of management consulting. We have a group called Invent that does that. And then we have a group that does technology. And then we have a group that does business services. And then we have several services that cut across all of them. They're called global business lines, and we're part of a group called Insights and Data, which is a global service line. Right now, as you can see on the screen, we're 210,000 employees, but with the recent acquisition of a very large company called Altran, or at least a relatively large company called Altran, that's actually up to 250,000. We're in 44 countries. The annual turnover, which is actually revenue for us in the US, it says 13.2 billion. That's probably after the Altran acquisition, about 17 billion. We have 25 innovation centers and 6,000 plus clients across the globe. We have a fairly good presence when it comes to clients. We have 9 of the top 15 banks, 12 of the top 15 investment banks, 12 of the top 15 insurance companies, 8 of the top 15 asset finance companies, and 9 of the top consumer finance companies. So we're trusted by large clients across the globe. Beyond that, we also have a fairly strong domain focus as well. So we have actually sub-strategic business units for insurance and banking. So we have deeply sort of experienced people within the insurance group as well as for the banking group. In terms of our capabilities, it's really the data value chain all the way from going and finding data, organizing the data, governing the data, getting the data together, arranging the data for analytics, and then doing BI/analytics on that, and also advanced analytics visualization and deployment, those kinds of things. When we think about our way of working with clients, I would say that we like to adopt a collaborative style. So we're not doing things to or for our clients, we're doing it with our clients most of the time. So we try to be outcome aligned, and we try to be very, very flexible when it comes to different engagement models. And if you don't have one that sort of works for you and you have an idea for that, we're always willing to listen to ideas. And we also deliver at scale. So we just have, over the last 50 years, delivered big and small projects. And over the time, we've actually created methodologies that sort of ensure good delivery practice. We're also known for our thought leadership in financial services. So we actually bring out a bunch of different research reports, like the world reports in fintech, world reports in insurance, world reports and payments, and so on and so forth. I should also give a shout out to the people at Capgemini here on the Capgemini Research Institute side, because they're one of the best ranked in-house thought leadership or think tanks in the industry. Going to the next slide, it's a little bit about insights and data. I'll just talk about the number of people we have to give you a sense of scale, but then I'll skip over the rest, and then I think we can get into the topic of cybersecurity analytics. So we're 16,000 professionals across 40 plus countries, and you can see all the countries where we're represented. And as we said, they sort of run the gamut from getting data and organizing data to actually delivering insight and deploying insight into transactional systems. Last slide about Capgemini, I promise, and this is actually some sense of credentials of Capgemini when it comes to insights and data. So on the Gartner, Everest, and Nelson Hall evaluation of vendors that provide services in the space, we come out pretty strong in all those evaluations, so we're rather proud of that. With that, we'll skip to what the big motivation is for people to do cybersecurity analytics today. So there have been sort of like an evolution in 3 separate dimensions that's driving an increasing need for more, better, more effective cybersecurity analytics. One is along the technologies and this sort of explosion in terms of from an infrastructure standpoint, network standpoint, endpoint standpoint. The number of technologies that are coming into play and the number of vendors that are coming into play has just made it a very, very complicated situation, with all kinds of new threats sort of coming into the realm because of all these new technologies from different vendors and so on. The second dimension that's actually worrying people that sort of are responsible for the CISO and CISO offices is the threats are evolving as well from the standpoint of some negligent sort of problems with the threats. There are threats from non-feasance as opposed to misfeasance, I would say, all the way to like state-sponsored threats that we're seeing today. That gives you a sense of the kinds of people that are involved with these, or I should say, the kinds of bad actors we're seeing has really gotten a lot of different kinds of people. So we see that, and also the amount of sophistication they have in terms of the threats that they can actually perpetrate on our systems has actually grown as well. And then, of course, regulation expectations as well, as from PCI DSS to HIPAA and PSD2 and so on and so forth. There's more and more scrutiny on the system that we actually use for preventing against vulnerabilities, detecting threats. So a lot of times we are called upon to explain the systems that we have, and there needs to be some assurance that we need to give to regulators that we have a great system or good enough system to avoid threats, and also that we're actually following that system. I think that's always a good start. It's possible in the cybersecurity threat space that we can't prevent 100% of the threats that sort of come to our door, but we ought to be able to actually explain to regulators what the process we have is and how we actually follow those processes to do the best job we can to protect our data and our users' privacy and so on and so forth. The next one is kind of like gives you a perspective as to how to think about threat protection. So if you really think about how castles work, at least the historic castles with the moats and multiple walls and redundant protection zones, so on and so forth, I think that this is a great metaphor for. I think that we can build systems based on what we've seen in the past, but then there's always new emerging polymorphic threats that's very hard to defend against. So from that perspective, it becomes very, very important for us to not just look at things we've seen in the past, but also the things that just look weird that warrant an investigation. On the next slide, what we're switching to is how we think about bringing the best of cybersecurity analytics to our clients. And I'll focus on the picture here, which talks about in the blue area there, or the blue line, we're talking about security research. And what that refers to is the fact that we're trying to be very abreast of what's going on in the cybersecurity world, both in terms of threats and how you actually defend yourself against the threats, or threats that have already happened and how you actually remediate once the threats have happened. So from a forensic standpoint, understanding what's out there is what the security research aspect talks about. The second aspect is the client objectives and environment. So it's good that we know what's happening in the industry, but we also try to do a pretty good job, or a thorough job, I should say, not a good job, that's up to the client to decide, in terms of what they're trying to accomplish and what are the specific threats that is peculiar to their industry, their operation, and so on. And that sort of informs the kinds of solutions that we bring. And of course, the data science aspect of it, which is all about looking at the data, how we pre-process the data, how we bring it together to basically sort of bubble up the potential threats, and then basically be smart enough about not bringing all those to SMEs, subject matter experts, but just be very, very smart about just bringing the really, really relevant ones, or the ones that get bubbled up. Sometimes it's through actually combining multiple data science approaches. Sometimes it's about sort of combining the data science approach with SME intervention to make sure that we're bringing the best possible threats for people to actually action. So we combine these three things in terms of how we actually build applications in the cybersecurity analytics space. On the next slide, what we're talking about is how do we go from data or what gets produced naturally by the various systems and endpoints and so on and so forth, to actually finding things that need to be bubbled up if it's not already causing damages, or if it's actually causing damages, how do you find what the root cause is and go fix the root cause. So here we're just showing you a funnel-based approach. From the top, we're showing you the kinds of things that feed data into us that are produced naturally through normal activities. And then basically we apply a security lens through it through SIMS and AI machine learning in terms of bubbling up anomalous activities. And then on top of that, we provide some kind of domain, I shouldn't say, we provide good domain and technology expertise on top of that to be careful about curating exactly what we want to show experts to action. Potential threats is basically looking at things to action, and sometimes we're able to also not only say this is a problem, we could also provide some insight as to how they might be remediated. So that's that. And then the last one is, of course, investigations and threat containment, where something's already happened. How do you actually go find the thing that's sort of ostensibly looking like a problem and has caused damage back to what the root cause of that is, so we can go back and fix that. On the next slide, we are talking about Capgemini Security Analytics Services portfolio. It's like, as you can see, an end-to-end offering. So there's three parts to it. The first part is the threat synthesis and contextualization. The second part is detection, and the third part is defense and response to it. So under threat synthesis and contextualization, we're talking about we provide advisory services when it comes to security and threat assessment. We also provide design and architecture services in terms of tool evaluation recommendation. We have some sort of specific thoughts about how we can get started quickly using some stuff that we have from partners, of course, Elastic being a good example of that. We'll get into that in just a few minutes. And then also setting up the target operating model in terms of how do you set up the people, process, technology interventions or structures to both catch threats, sort of to prevent damage, and also to remediate threats after they've happened. Under the detection chevron at the top, there's multiple, I guess, classes of use cases or applications that we try to build. The first one is the user and entity behavior analysis. And what we're talking about here are the kinds of use cases where we're looking for, when we combine the user that's involved plus the infrastructure they're interacting with, basically looking at that from a behavioral standpoint and surfacing things that might actually look odd. So for example, you have certain amounts of data going out for a particular user group compared to peers. during the weekdays, and we see a different pattern for the weekend, we can actually look at, for a specific user, if that sort of data movement pattern looks the same as the peers, both during the weekday and weekend, and then try to actually surface things when it looks odd. So for example, you might see that the rest of the peer group has low data movement over the weekend days, but then you might have a specific user that has a high level of usage, and you want to actually be able to bubble that up. The second kind of use case is breach intelligence. So we're talking about looking at just a lot of times just what we're seeing within the infrastructure telemetry and logs, and some don't always have to have reference to the user, but then just from looking at what's coming from the logs and telemetry, can I tell if something's odd, or are there examples? And this, by the way, applies to both 1 and 2. On top of being able to tell or call out anomalous behavior, there might be past history of things that were investigated and actually actioned. If we have that on top of anomaly detection, we can also build predictive models that basically says, based on what I'm seeing for this user, for this infrastructure, in the past, when you've seen these things, they've tended to be problems. So you should probably look at this one because this looks like you would have actually done something with this. So you did something with this in the past. Looking at the past data, I can tell that you've done something with this in the past. Therefore, I'm asking you to look at it. The third one is dashboards and reporting. What we're talking about there is rather than just doing the detection part, how do I actually bring that to the user in a way that's consumable? So if I just start pushing out lots of tables and data to people, it's very hard for people, even experts at this in this field, to be able to find what they need to find. So I think there's a bit of design that can go into how we design visualizations, dashboards, and reports, so that we're focusing the experts on the right kinds of things. And the last one is threat forensics. What we're talking about here is, of course, the last piece of the funnel diagram, where once we see that the threats happened and it's starting to cause damage or has already caused damage, what can you do to actually trace it back to the root cause and go remediate that? The last chevron here in terms of our offering is the defend and respond stuff, which is basically, can we actually help with creating operations procedures or operations manuals for SOCs, and then goes beyond that to providing actual SOC support for our clients. This is where I want to spend a little bit more time, so I'll probably spend 5-6 minutes on this slide in terms of what we're trying to do that's different than your plain vanilla cybersecurity analytics approaches. And the simplest way that I can explain how we approach this is we take a very paranoid AI approach. And what that means is that rather than relying on one AI ferreting out anomalies or ferreting out things that need to be remediated from the standpoint of what we've learned from past data that required remediation, we're actually building multiple models and multiple ways of looking at these things and having them kind of vote, if you will, on whether something is a problem and whether it needs to be remediated, right? So as I'm going through this stuff, just think of paranoid AI as fundamentally how we think we're trying to come up with a good cybersecurity analytics system that brings the best curated threats for people to action rather than just create an explosion of things for people to look at. I think that's really a problem with a lot of the solutions today, is the number of false positives that people have to deal with. If you look across the top, what are the things that are required in terms of building out a good solution? There's a little bit about data collection, I should say, that's kind of important. And there's some post-processing required, pre-processing that's required depending on where you're getting the data from. If you're getting stuff from infrastructure, you might be able to use information like memory utilization, CPU utilization, and so on and so forth. And you might get those as quantitative metrics, but then if you look at applications, APIs, and containers, those won't make a whole lot of sense. And what you have to do with that stuff is actually resort to what we call synthetics, which is basically looking at the metrics that are coming out in terms of delayed latency of applications and things like that that might actually give you or clue you in on what the problems might be. So there's, on top of the sort of metrics that come directly to us or metrics that need to be created like the synthetics, there's also a bunch of logs that become available to us that we can leverage as well. Some logs, it's easy for us to handle because they look like standard logs, but sometimes we also get some non-standard logs, in which case there's the need to pre-process that information. The whole point is whether we were looking, so I'm actually looking at the left-hand side here, networks or servers slash VMs or applications or APIs or containers or files, what needs to happen from all those different things is we need to get KPIs, and we don't want to look at KPIs at one single point in time. We want to look at a time series of those KPIs and use those to drive how we look for threats. In the second column here, we're talking about basically the categories of data that come out of the sources of data, which was in the last blocks that I read. So as I said before, there's telemetry data, there's some IoT data we could have access to, there's some log data. And then of course, Ruben, my friend from Elastic, is going to talk about APM and how they could provide a rich source of data for cybersecurity analytics. So in the second chevron there, log parsing, aggregation, and processing, I touched on that a little bit. It's part of the data collection phase. It's just part of the pre-processing phase. And then, as I said before, in the AI and machine learning chevron, which is a gold chevron, the third chevron there, it's all about how do we actually look at weirdnesses in transactions and so on and so forth from multiple different ways. So I've seen many vendors talk about anomalies, but there's like so many different kinds of anomalies. So there might be outlier anomalies, there might be novelty anomalies, there might be compression anomalies, which is where basically you compress the data and try to decompress it and see if there's anything weird about the reconstruction that we did. There's, from a factorization, we might actually try to do the same thing. From a frequency anomaly, so there's, for example, an algorithm called restricted Boltzmann machines that looks at, for example, a combination of features that should show up like 3% of the time suddenly start showing up like 15% of the time. That might give you another clue into what kind of weirdness we're looking at. All that to say, we're basically looking for multiple perspectives on weirdness, and then we use those as actually additional variables to basic variables that we had from before, and then using all those, and in cases where we have past examples of where SMEs have looked at the output that came out and said, yes, this is actually a problem that needs action. In those cases, we're actually using that data to build a further prediction engine. So we use the basic data, we add the anomaly data on top of that, and then we used historical data as to what was actioned and what was not actioned to build a prediction engine to drive what we're actually throwing in front of folks. So once we have that together, both from an anomaly standpoint as well as prediction standpoint, we try to throw it up on a UI generally. Sometimes we actually try to drive it through Kibana, which I think Ruben is going to talk about. But then sometimes we also think that there's a graph visualization that can be helpful. So this is where we're talking about insights. How do we deliver insights, which is the green chevron at the top after AI and machine learning, is presenting that anomaly information, presenting that prediction information, presenting the root causes. We do that through dashboards as well as graph visualization. And that's what we're showing to security analysts. Hopefully what we've done relative to other vendors in this space is that when other vendors in this space are showing 1,000 alerts, we're showing a lot fewer alerts than that for actioning. We just want to make sure that we're doing everything possible to give the SMEs a fighting chance at actually actioning this. I'm going to flip it over. Ruben is going to talk about APM in just a minute. Before that, I just want to talk about a brand new technology that we're focusing at Capgemini, which is on the next slide. I'll skip this one. On this one, I just want to talk about this because I'm about out of time. The latest technology that we're starting to play around with is called topological data analysis. And what that lets us do is basically represent observations as space, basically points in n-dimensional space, and then basically looking at that shape of data. So what do we mean when we're talking about shape of data? We're talking about things like adjacencies. We're talking about things like distances. We're talking about things about the closeness or openness of data. And the real awesome power of topological data analysis, and by the way, this has been around since 2000, so it's about 20 years old. It took a lot of time to actually start driving value out of this, but I think we're at a critical juncture now where we can start driving data out of it. The biggest value that we get out of this is that we might be able to actually do some very quick analysis in terms of taking the data that's coming out of all those sensors, whether it's text or numbers, and basically looking at the text data without doing a lot of pre-processing, and also looking at all data in terms of as time series as opposed to a cross-section in time, and then basically looking at what things are clustered together. From a practical standpoint, the neat thing about topological data analysis is that if you find just a few examples, so imagine you're sitting in a security operations center. If you find one, two, or just a few things that are problematic, it's very, very easy to go and try to do a visualization that tells you other observations that are very, very close to the problematic things that you found, where you have to actually action it. And then you say, for example, in this, I have circled a small set of blue dots, and you see that the blue dots there are problems. They're actually bot problems, but there are some gray ones in there. We don't show all the gray ones because the blue ones are hiding that, but we can actually magnify this stuff. And we can see that there's a lot of gray dots in that group as well, where you're saying, hey, these things actually got surfaced, but then there's some gray stuff that didn't get surfaced. What's the issue with that? Can I actually open that up and see what's going on with those things? So in this, there's like a lot of blue dots, but even with just a few observations, you might be able to basically say, okay, there's this 3 or 4 things that look like this kind of problem. Can I actually do a quick TDA and see what things look like this so I can go action that? So that's the end of my part of the presentation. I'm going to turn it over to Ruben to really talk about the red box here, the APM, which is basically application monitoring data that's coming from these systems and how those actually get used in cybersecurity analytics. Ruben, over to you.
Appreciate it, Rajesh. Thank you, folks. If you didn't catch it in the beginning, my name is Ruben Perez. I'm a solution architect with Elastic, and today we'll be talking about APM. So let me start sharing my screen here. Now, if you guys can indulge me, would you mind if you've used anything in Elastic prior or heard of Elastic prior to today, could you do me a favor in the chat, just put a plus and how you heard of it or how you're using it? And could you give me a double plus if you actually are leveraging our application performance monitoring and how you're using all that, just to get a sense of how we can wrap this up at the end. Okay, with that said, I hope everyone can see my screen. I have a pretty long or longish deck, but I'm just gonna give you guys a few slides before we jump into a demo. Unless you guys have more questions, and then feel free to fire up the chat and I'll do my best, and Rajesh can keep me honest in terms of answering those questions. So for those who aren't aware, APM or Application Performance Monitoring is one of our solutions that we provide within our Elastic suite. And effectively helps you retrieve host level information as well as services and application in real time or as best as you can programmatically to make sure that your system is not only performant, but behaving properly. And by that, I mean, it's not having any issues, any errors. If there are, our APM agent will highlight that within our system, and then you can visualize that within our user interface Kibana. I'm gonna go ahead and show you a quick architecture of how APM fits into your enterprise, your network, right? So we have APM that can track your log information, your infrastructure metrics, and things of that nature. As I mentioned, we have APM that could fit with your software applications. DevOps folks are very interested in that. And then we have our APM agents that can track some more of your containerized data sets if you have containers and things of that nature, like Kubernetes and whatnot. Our APM agent and servers support a whole slew of technologies, from our different code bases, Java, Python, Go, .NET, Node.js, and Ruby, all the way to real user monitoring with the favorite browser of your choice, as well as the Apple and Android markets. We also support the Angular, Vue, and React frameworks for those who are interested. Now, I'm going to pause my slide right here and actually jump into a real-world example, or how I'd like to call it. Again, if you guys would indulge me, go to your favorite search browser or whatnot, and what I want you to do, or at least imagine with me, because this is setting up how we're going to do our scenario within Kibana, is type what I would call a potential malicious entry in a free-form text box. So I have it copied so I can paste it and save some time here. Now, on the surface, most search components might see this and say, I don't know what necessarily you're looking for, so I might just spit out gobbledygook, or I couldn't find what you're looking for, or something to that effect. But me being the malicious end user that I am, I'm actually trying to trigger my executable that's in this URL site path with these particular flags, so that I could potentially get into your system via website injection attack and then grab PII or other business information that I should not have as a malicious user. Now, most search providers will handle this in a number of ways, one being translating that whatever search text you have into an actual string field instead of something else. But that's not quite what I want to get into. That's a whole nother talk for another day. What I want to impress upon you guys is when you enter something like this, this would go through your code that services your website and get stored in the log or something somewhere. And to be quite honest, it might not be captured, because this might not trigger an error behind the scenes. It might just say, I couldn't find what the end user was searching for, I'll move on.
Yeah, hey, Ruben, there's
Yeah.
Ayush. Yeah, I think we can't see your screen.
Oh, no. Hold on. I was talking for a good 2 minutes there without that. My bad. Did you guys see the deck before I jumped out? No?
Yeah,
Yes,
maybe
it's on the deck.
last part of
Okay,
it.
my bad. All right, so all I did was fire up google.com and enter this search screen. So my apologies, folks. Thank you, Ayush, for pausing me before I got too far into the weeds. So getting back to what I was saying, this request might just get logged somewhere, and depending on how your DevOps team and your security team are set up, you might not capture this entry. Now on the surface, again, it could just be a search that did not yield any results, but me being the malicious end user that I am, that's perfect for me, because now I found a potential backdoor into your system, into your network, to grab whatever information I want, to be honest. What I'd like to show you guys with our systems is how our APM component can not only help leverage any particular errors in a code that might be triggered by something like this, but then how that's fed into our SIM threat hunting solution that could then help prevent future injection attacks. So I already have my demo system fired up. And what we're looking at here is a sample of a machine learning visualization that's showing anomalies in the system. This site had various code transactions that were going on with various users that are triggering said transactions. Now, quick blurb about what's going on here. Within our Elastic system, specifically machine learning, when it shows anomalies, the darker the red hue, or I guess brighter the red is a better term, the more anomalous it is. Now, anomalies, depending on who the observer is, could be positive or negative. In this scenario that we're talking about, anomalies are bad, they're negative, and we want to make sure we nip it in the bud as quickly as possible. Now, the information that's being presented to me, again, I have my left nav of all my offending users or influencers that are triggering this anomaly, as well as the transactions that are doing the same. And it propagated the highest anomaly, which is a severity score of 94. Now, there's a lot of math that's involved to get that percentage and that score. I just want to highlight it because it's higher than any of its predecessors that were under it in that table view. Quick note, we know that the influencers, again, are by the particular transaction that's going on, and the most influenced, or the highest influencer of all the possible influencers that are on the left is this Dale M character. And it's found for the code call update owner that's happening in my website. So what's going on is I went to the website, I wanted to change my address, for example, and I clicked update owner, and that, for whatever reason, is triggering an anomalous event. The particular machine learning job that we have going on for this is a high mean transaction duration. So something that took longer than I expect, basically. What we could do is go ahead and jump into the APM analysis of this anomalous event and see if I can drill down into what particularly is the issue. Now, I see a few graphs that are presented to me and a chart of sorts. One thing I want you guys to note, if you haven't used our machine learning components, I highly suggest that you do. But for those that haven't, this shaded area is something that's being triggered by my machine learning job, and I want to dig a little bit deeper into it. So as I sort of drill in and getting more detailed in terms of the stats that are being presented, I don't know if you guys noticed, but the transactions that were going on down here, this update owner propagated to the top. And this correlates to what we just saw in the last screen, because that was the highest anomalous event given those two influencers that are, that's the highest influencer for the anomalous event that we saw. So I'll go ahead and click in on that. And again, I'm presented with additional information. Specifically, I want to point you guys out to this transaction duration time. Now, it's highlighting this one that took particularly 8 seconds, but you can see that there are a couple that are taking longer than expected. And this is our whole APM stack view of the update owner call. It triggers a put API call that translates to an HTTP request, gets down to another put from the API, all the way down to this validate zip code. Now, prior to the validate zip code, we got this error that was triggered. Go ahead and click on this error and see this information. This is the culprit of that particular error. Again, it could have triggered our long wait time, and that would be propagated up in the APM stack view that we were talking about. Again, I want to impress upon you this particular error message and tie it back to what that funky Google request that I made before. Imagine instead of these 1s and 2s and 1s, which is an invalid zip code that someone entered when they were updating their information, imagine that being this executable request through your browser. That could show up as an invalid search request, right? Our APM agent can effectively not only highlight that there was an invalid request that could have taken too long of a time, which would trigger our machine learning job, it could give you the line of code that it actually got hung up in. So from a DevOps perspective, this is great because now I know where I can go to go fix my code to address these issues. But let's say by that point, this particular attack might have been too late, unless this information is being fed into our security side of the house with our SIM threat detection solution. So with the release of APM 7.6, we can now push APM-specific data into our SIM solution and leverage that by generating what we call detections. Detections are considered a predefined alert of sorts that if something were to trigger said detection, the SIM solution would then let the end user know, most notably the security team, that something that you triggered before is definitely happening again, and you guys should go in and hunt and potentially prevent this from occurring and reoccurring. let me go ahead and check out our managed solutions. Now, with the release of 7.6, we do have 4 built-in APM specific signal detection rules, but that doesn't necessarily limit you to just those 4. You can go ahead and set up something that is watching exactly what I entered here in the Google, where it says, you can say web application suspicious activity, weird or potential malicious injection attack. Again, we come with these 4 out of the box, but you can apply more. So what does that mean? What's going on? Let's say we do have our injection attack. I'm not going to go ahead and create the rule because that might take too long. And with live demos, my experience is sometimes it doesn't flow your way in terms of a live demo. But what I would like to show you is that when you do generate a rule, in particular, let me close this here. Again, live demo, my apologies. It'll show you all the signals that might have triggered that rule, if it's a high, low, or critical severity, things of that nature, risk scores, and so on. You can leverage this information to build your timeline of a potential threat. And this will facilitate that finding that needle in the haystack so you get a quicker mean time to resolution for threat detection and prevention. Before something like this, DevOps would just more than likely fix their code and leave it as is. And the SOC folks might not know this issue existed unless it came from a different log or a different source of some sort. Now with the marrying of the two, you can get all that rich information in addition to HTTP requests that the code is doing and build these timelines so that you can see if and when a potential threat is happening. Now, hopefully I did not, no, I'm still sharing. I effectively went through what my slides were talking about and building said signal detection. I wanted to open it up to questions now because I know we're running up on the clock here, but hopefully that presented some clarity on how you can leverage APM beyond the general observability play where you're tracking logs of your infrastructure or servers or network or things of that nature, and how you can take it to the next level and actually help facilitate threat detection. Because this day and age with everybody forced to work remotely, 2 things that I personally have seen propagate to the forefront of need is security and performance monitoring. And with our release of 7.6, we kind of marry the 2 into a single solution stack that you guys could leverage if you have Elastic. And if you don't, that's why me and my colleagues are here and Capgemini. We can all help facilitate you getting your hands on some Elastic trial and whatnot. I have a slide here later in terms of if you guys want to learn a little bit more about Elastic. We have great training and things of that nature. So we're here to help you. And I hope that was helpful for you guys. So Rajesh or Ayush or Faith, I'm not sure who I'm swinging it back. I think it was Rajesh. My apologies, man.
Yeah, I think we're opening it up back for questions.
Right. Let me stop sharing and check the chat because I know I asked you guys to do a little bit.
Not seeing any questions in the chat or in the Q&A right now.
That just means Rajesh and I answered everybody's question and we just did that creative a presentation, huh? I do see a few people had put a plus that they've heard of Elastic or touched it. Would love to hear or read a little bit more if you guys are willing to share on how you're using Elastic, if you're leveraging any of our security solutions. Nope. It's a quiet Tuesday, I presume.
So Ayush, one of the things that I saw, I don't know if you're actually live on the microphone, is You pointed out Elastic and enterprise discovery and also knowledge graph. If you want to give like a few more words, maybe I can just jump on top of that. Give me a little bit more context, me or Ruben can.
Oh yeah, sure, Rajesh, right? So see, a lot of our use cases, right, are beyond the basic logging aspect of Elastic, right? And where we see a couple of use cases come up, especially with our enterprise clients, right? And even on the banking side or wealth management side is how are we leveraging this, the optimized storage of Elastic, right? The graph ability of this tool, and also building the semantic layer, right, which becomes the enterprise data discovery tool, so to speak, and it also enables data governance or even like a better governance, right? So what's your take on that, Rajesh and Ruben?
So maybe I can start off. So the way that I would look at this, right, is once you actually have done the pre-processing, we've done some of that semantic processing already. So from the standpoint of how we're looking at graphs, it's working with data that's somewhat standardized. And what we're looking for is adjacencies and connections and so on and so forth to come to the root cause analysis thing, right? So that's how I'd look at the graph piece. On the, I didn't quite catch, Ayush, what the second question was other than the graph one, the use cases one.
Yeah, this was on the enterprise data search or kind of the search capabilities, right?
Right.
Yeah. Mm-hmm.
So I would say that, Elastic is basically extremely, I shouldn't say basically, it's an excellent search platform. And one of the many things it does is also sort of helps us with the cybersecurity analytics in terms of helping us look for sort of structuring data to bring out trends and issues and so on and so forth that can be fed to Kibana to visualize, right, or to threshold and visualize. So the way that I would look at it is that we're looking at a particular capability of a broad search platform like Elastic to drive the cybersecurity analytics use cases. I think that that Ruben will have a much more elegant way of explaining it than I do.
Yeah, I'll try to say it in a different light because Rajesh, that was great. Our DNA as a company, as a people, we're built upon search. I mean, Elastic is a search company. I went into APM today, but the underlying tone of the APM capabilities is just allowing you to search for data in a different light, right? Our machine learning is allowing you to search for anomalies at a quicker rate instead of sitting there and sifting through 20, 30 screens of logs and things of that nature. Our security features are allowing you to search for potential threats or prevention of threats that might have already gotten into the system. You can sort of cut it off at the pass and take that infected endpoint offline. So all the underlying bits is search. Is just how we present it or how the end user consumes it. They might not realize at the forefront that it's search, but behind the scenes, we are allowing them to search better, more efficiently, and quicker.
Okay, yep. That was good. Another question, right, is so Elastic does have a cloud subscription or a solution, which is ECE, right? And I see that as a deployable product, even for like banking clients where the sensitivity towards going public cloud is kind of, it goes through a lot of InfoSec checks, right? So there is an aspect of ECE being locally under a VPC or a kind of a VNet environment for a banking client. So Ruben, is there a way you can kind of shed some light on the deployment aspects of going on cloud versus what you have seen for other banking clients?
Yeah, for sure. There has been quite a bit of a push for cloud adoption. Again, because of the times that we live in now, it's almost mandatory if you want to keep your business going. But we do have our cloud offering that we run in Azure, GCP, or AWS, and that's our Elasticsearch service, our ESS offering. Now, if you want a cloud-like experience, but you want to manage and orchestrate it yourself, that's where our ECE or Elastic Cloud Enterprise or Enterprise Cloud, Elastic Cloud Enterprise would be deployed on your on-prem. And that on-prem can be wherever you'd like. It could be virtually, it could be bare metal, it could be a hybrid solution. Effectively, the benefit of having our cloud offering, whether it be on-prem or in the cloud, in the traditional cloud space, is that the orchestration and to some degree the infrastructure is easier to manage, or you don't need to manage it at all, right? So you can have one or many clusters that are managed from a single interface by one full-time employee that might not even be dedicated to Elastic. And that one person can manage, orders of magnitude of clusters. I mean, internally within Elastic, we use ECE to manage our Elastic system as a whole. And I think we have a handful of admins that manage it, and that's only because of the different time zones that we need to administer to. Otherwise, it could be just a couple of folks that are managing, hundreds of clusters. I hope that answered your question. If not, I can get a little bit more deeper into it.
Oh, yep, it did. Yeah, Ruben, thanks for that. So I don't see any more questions here. So Faith, I think we're good on this one.
Great. Well, thank you everybody for joining. If you joined through the Mayor virtual user group, I will be sending you a follow-up email shortly with a recording of the video. And we hope that you tune in next time. Again, in the chat, there are some links to Capgemini's Insights and Data Meetups groups. So thanks for tuning in, and we hope to see you again. All right. Bye, everybody.